Okay, so this is a video to help you through the assignment with Trebuchet simulation. The Trebuchet introduction should help you figure out some dimensions that will help you out. Okay, so some of the main things you're gonna have to worry about are the short arm, the long arm. So the whole arm itself needs to be about 16 inches. And so if we divide it into the short and the long to let you know where the pivot point is right here, okay? Even though it's all one part, we say short and long just to say that. There's another thing called the center of gravity, which would be, where does it balance, okay? If you were to take this off and balance it on my finger, where would it balance? That's the center of gravity. Anyway, so the length of the sling is how long is the sling when it's actually attached, like this, okay? And as this thing flips around, the sling slides off and then lets go of the projectile, okay? So it's kind of like a catapult with a sling, and it's kind of fun. Anyway, another dimension is how high up do you drill the hole, okay? Notice how this group moved it up, all right? Because they figured it out that they would have more room for the weight to swing through if they did so. The weight is going to be a small water bottle. Now, little tiny ones, right? And the challenge is how do you make this as heavy as possible? This one right here is full of pennies and sand, and it weighs a little over 2 pounds. So it's like 2.3 pounds. The heaviest I've ever seen probably got around 3 pounds, a little over 3 pounds. So, and I think they used like a whole bunch of BB bullets from like their BB gun. Anyway, so obviously metal is going to be the heaviest thing, and pennies are the cheapest thing that we've been able to find because they only cost a penny, right? And so on and so forth. But before we build it, we want to make it good, okay? And one of my favorite videos to show how mechanical engineers do simulations before they build something is this video by Mark Rober called Car versus World's Strongest Trampoline. And he designs a trampoline and then they build it. And you see his design at the beginning, but then he talks about his job more at the end. So if you watch this is kind of just for fun. Watch this video because we'll watch it in class. For those of you at home, we'll have to just kind of watch it. I'll put a link in there after I'm done with the video. It's not there right now, but I'll put it in there. And so let's go ahead and come in here and look at it, okay? So Trebuchet simulation. All right, so video coming soon. I'm making that right now. Anyway, so what you're gonna do is you're gonna go to this website. Boom, here it is. And here's a little design of a trebuchet right here. So you see the blue line for the short, then here's for the long, the length of the sling. Okay, so if you see these measurements, those are the main measurements I want you to give me for this right here, draw a sketch. Okay, your sketch doesn't have to look any better than that. Let me see if I zoom in here. So if you were to like take a screenshot of that, but replace these with actual, or you don't even have to take a screenshot really. It's just you draw these, but draw these with to scale. So if it says that it's 3.2 inches, if you switch that to centimeters when you're actually drawing it, you can fit this on a sheet of paper because this right here, this is like actual size. This wouldn't fit on a piece of paper, but if you shrunk it down and use centimeters instead of inches, even though you're going to be building it inches, you can fit it to scale on a piece of paper and say, hey, this is what mine is going to look like, and kind of use it as a guide when you actually build yours, okay? Anyhow, so there's all that. And but it starts out with all these um, measurements in here that I pre-did for you. If you click the link, it enters them in, puts you in the right mode. Okay, and all you have to do is click submit, and it will launch. And it's a horrible launch. It only goes 2.5 feet. So let's look at the other link I have here. That's the worksheet, and you can import it into Google Sheets. So if you just download it, but then go to Google Sheets and open a blank one and then say import, it'll open it up just like it'll work for everybody else. Okay, but I'm just going to use it with Excel, but this will work if you download it and open it, import it into Google Sheets. All right, let's open it. Enable editing so you can actually change numbers. Now what we're going to do, I ask for 10, but if you do 12, that's a 4. If you only do 10, that's a 3, whatever. So these ones are for before, and then after we actually build it, we're going to weigh it and try to put all these values in for the real deal after you build it, and then put it in here. And there's still a couple things you can change after you build it. Like you can still change the length of the sling. And so you can like put in all your info and you'd be like, okay, what's the best length for the sling with what I have, with what I was able to like weigh this exactly and put it in. Right now we're just guessing. Okay. And so on and so forth. All right. So what you need to turn in is basically, you can do a screenshot of this or you can just turn this in. Okay. And I want to see at least 10 simulations that you did. So all you have to do, if you just copy paste these over, and please read this right here and all this right here, because you can see I don't want you changing these numbers, and these two right here need to add up to 16. So if you change one, make sure you change the other so that they add up to 16. That's something that a lot of students mess up on. Okay, and this I'm giving you a hint. Hey, it should be close to the length of the long arm. Okay, so if the long arm is 12.8, then 12 is close to that. And you can see what would happen if I change that. Will it make it better or worse? Anyway, one thing that I would highly recommend to change right off the bat is the height of the pivot. They have it set pretty low here. And so if I were to just change that and go all the way up to 11, and let's just change that one thing. And to let me know what you changed, right here, highlight it in yellow. Also, if you're like, hey, I'm going to make this thing heavy. If you have a bunch of pennies and you know you're just going to throw a bunch of pennies into it, then you could probably expect to get at least 2 pounds out of this thing. The one that I have is like 2.3. So I'll just put that in because I know I have that much. All right. Or at least I know you can get to that much. If you put 3 on there, you're going to have to find something better than pennies. Okay. Like the BB bullets and stuff like that, or heavy metal. If you have some old drill bits that are really heavy, like the steel that they make drill bits out of and stuff, especially you can find some like carbide mill bits and stuff, they're super heavy compared to regular steel. That would make something probably even heavier than 3 pounds. Anyhow, but don't put in heavier than 3 unless you know you can get it heavier than 3. That's just the best I've seen in a long time. Anyway, so I'm going to highlight both of those because I'm going to change. So 11 and 2.3. So I'm going to go back to the simulator and change this height of pivot to 11. Just see what that does by itself. That right there almost doubled it. It's almost a 4. So let's also take this and make that 2.3 and submit. Oh, there we go. Look at that, 16.759. I can actually just copy that. See, and then come back here and say, okay, so here's the distance right here. You can put right here and go Control V. And you can say match the destination formatting and it'll make it there. Or you can just remember and type it in. So you see right here, here's a test links right here. So if you ever want to go back to that, what you can do is click this and then Control C and then come here and be like, okay, so test one. If you ever want to go back to your test one, boom, you can click that link and it'll put these numbers in. You don't have to go in and type them all in again. So if it's like, oh, I want to go back to that first test I did and change this instead. This makes it easier so you don't have to type it in later. That's not absolutely necessary. I'm not going to come down here and expect to see all of these put in, but it's there. I put them here so that you can, if you really want to be precise about this. Okay. Anyhow, after you're done with your first test, then copy these and then paste them right next door. And then you can be like, okay, let me try something else. What if I were to make this 3 and this 13? Notice how it did the math for me when I click down there. Okay, so 3 and 13, what's going to happen if I go 3 and 13? Well, let's test it. 3 and 13. So I'm going to submit. Now it goes 15.1. So I come back here. I'm like, 15.1, that's worse. So what I could do to let me remember that that made it worse, I could highlight those in red and say, you know what, that did worse. So that's not good. So instead of copy pasting that one, I'm going to go back to my first one again, Control C, Control V, and instead, what if I went to 3.5 and 12.5? Let's see what happens. So we go back to this 3.5 and 12.5. Test it out. And wow, it does better now. Wow, that's good to know, right? So when we 3D print this, we'll make sure we 3D print it with the right dimensions. And we can still dial that in even better. So let's see, 18.327. Come back here. Okay, down here it went 18.327. It's not going to type them all in, it'll round. Anyway, so this did better. Okay, so these are even better. We can highlight those yellow or blue, whatever color you want to let you know, hey, this is better. This is the best one so far that I found. Red means something that I tried that didn't work. So it's okay to write down ones that you did that were bad. If you want to only write down ones that did better and not write these ones and just keep going till you get the 10th best one. And then you're like, I think after 10 times or 12 times, making it better and better, but I think I've dialed in on what's probably the best one so far. All right. So there's lots of stuff you can change in here. Some of these, like the pivot arm to CG, that right there. If you're like, I don't know what that is. It kind of tells you in that. So that first. Oh, shoot. Okay, so I think I told you what that was. I think the balancing point. So if it says 2 inches, that means if I were to disconnect this and I were to put my finger 2 inches away from the pivot point, that's where it would balance. Okay, but if I see how I made this really, really hollow, and then right here I made this solid. I did that on purpose so I could move the center of gravity more towards there. But if you make this thing, if I were to make this thing all solid, if I like made it out of a piece of wood and the balancing point was right in the middle, so this pivot to CG, if that was right in the middle, this is what, 16? And so, well, the pivot arm is there. length of short 3.5. So 4, that'd be 4.5. So if I made this, I could just click uniform arm, but we'll just say 4.5. I would have made it like that. Now notice it's 18.327. Now it's only 16. So that's assuming that I made this out of one big solid block of wood or plastic and that was all uniform. Okay, it wouldn't do as good. So if you think you can design something that's really strong but yet lightweight on this side and then put a little more weight on the other side, then you could say, oh wow, I think I can get this thing designed to a point where the center of gravity is right on the pivot point. What if we had it right there and you could balance it perfectly? And you tried that, and look, it goes even further. So, and then we're going to be later on, how heavy is the arm, like how heavy is this whole thing and stuff like that. But that's a lot of this stuff we're just guessing right now. And so I gave you some measurements for that to help you with your guess that you stay within. So again, your job is to completely fill this out, and I did the first 3 with you, so you'll only have 7 or 9 more to go, and then turn it in. Okay, and when you're done, you'll know where to put your pivot point, at least when we design our trebuchets on the Fusion 360. Okay, hopefully this helps. I got to get ready for my students; they're coming in soon, so. Have fun with this, and let's do a good job on it. Okay. All right.